Hi, welcome back to Byte Forever. In this video, we're going to look through debugging the Snake game. So I wrote this version of Snake for the ZX81 in assembly language some time ago. If you just look in the description, there's links to everything there. The code on GitHub is available to download as well from itch.io. So the description also has a transcript of this for those who can't quite decode my northern British accent, which is most people south of Manchester. So the game has a really annoying bug which I've been searching for off and on basically since the game was finished, in quotes. And what I'll do is describe the bug, then demonstrate it as it is in the original version, and then show the debugging version and some of the attempts to work out what was happening. First, for anyone who's not familiar with any of that, here's a quick catch-up. So, ZX81 is a small home computer that was developed by Sinclair Research, first sold in 1981, and it was made to be as accessible as possible to people who could not afford any of the computers which were on sale at the time. You could even buy it as a kit and save more money by building it yourself. It was very basic, only had 1K of RAM, read-only memory, and a calculator-style membrane keyboard. Despite its cheap build quality, it had a certain style. I think it actually won a design award for the industrial design. Rick Dickinson won that award in the UK. So it was quite stylish and actually quite powerful if you execute everything in assembly code or machine code. And there's a certain quirkiness that has become close to many people's hearts, mine included. Especially as it was for many the first computer that they could own at home. Assembly language programming is next to the lowest level programming you can do. The assembler, that is a program that, surprise, surprise, assembles your code into machine code. That's different from high-level languages that are compiled, where it's known as a compiler, so it's known as an assembler for assembly language. And in the process, it does some checks, allow you to write code using human-readable tokens and keywords. And these keywords represent the actual CPU operation codes, opcodes, such as LDA, LDB, if it was a Z80 CPU. So the advantage of assembly programming is that it translates almost directly into machine code native to the CPU. So it will run faster on old machines, especially compared to basic programs. May also take up less memory space compared to code written in other languages such as C or Pascal or even Forth. So there is a trade-off between ease of writing the code and sometimes the speed that it runs at or the amount of memory that it uses. So yeah, it's a double-edged sword. You're responsible for everything from memory management to even construction of loops and logic. And that is just trivial to do using high-level language such as C. It's not as easy in assembly. And now just a little bit on what a bug is. So a bug is a piece of code which causes the execution of something which isn't expected or causes it to crash or isn't what the program originally intended. So what is a bug? Well, it's a bit of code in a program which causes unexpected results, possibly causing the program to crash. It originates, as far as I can tell, as early as Thomas Edison, with some invention that he was doing, and he got a bug stuck in it, and he said he had a bug. And he referred to it back then as an engineering defect. So debugging is removal of bugs. So as I said, a bug is faults in software commonly that causes the program to crash. And as part of debugging, you have to search for clues when the bug happens. At that point, try to narrow down the root cause of it. Maybe put some so-called debug into the code, which might tell you something about the location of faults. And also, how repeatable a fault is makes a massive difference on how easy it is to find and fix. So back to the ZX81 Snake game. There's a bug in this game, and basically when you're playing the game, sometimes the snake characters, part of the snake, drop to one block below onto the next line or the next row. And if you crash into that accidentally, then obviously that's game over. So I'll just demonstrate that now. So the original game, the bug also happens at the same place every time you run a particular version, or it does change if you reassemble the code. So on this version, basically, you have to be quick to see it, but the snake actually drops one block lower, and then there's also a block dropped behind that, actually where the tail of the snake was. And it does it at the same time every time you encounter that point. So you see there. So that is essentially the bug. It's totally repeatable. So what could be causing that? I've been through several iterations of attempting to find the bug. And this next version of the game, I'll just close that one. Enable debug. And what I've got here is CPU registers. I've also reduced the size or length of the snake to 1. I've disabled collision detection. You can see at the bottom there's a row of hexadecimal numbers from left to right. They're the registers A, HL, DE, BC, and then there's a line of extra few variables there that I'm printing out, which are these refer to the row, the column of the head of the snake, the tail index, effectively how long the snake is, and the last one is the location of the position of the head of the snake in absolute address of display memory. See that now is 470. Well, it was 470, now it's 45. So you can see as you go down the rows, that increases more quickly because it's increased by 32 each time. So I've also made each character that the snake block consists of as a number, and that represents which direction that particular part of the snake's going. So 1 is down, 3 is across, 0 is up, 2 is across to the left, 3 is across to the right. So this is quite useful in allowing us to debug. So my first attempt at debugging then was to add all those extra features, and one of the things I noticed was when this happened, you saw there, that block got left behind. If I go there, also we got the point when that happened, the line of debug registers and variables at the bottom actually skipped up one. So now there's two lines, one of them's just stuck at the values it was when the fault happened. Now that wasn't my intention to put that debug in that way, it's just actually a result of the bug that's happened. So, and it also, every time that happens, it actually updates that line. Now, you would think that's a bit, well, it's quite useful, but actually it turned out not to be that useful. I couldn't work anything out from it. But it did make me think the possible reason for the bug is that something in the display of the ZX81, i.e. the display memory or references to it, is getting screwed up somehow. Possibly when you call print at, which is a ROM routine. So I'm just doing a quick search for that. Print out requires a few things to be set. I think it's register B for the row and register C is the column, as the comments say. That led me to think maybe I needed to save registers before I called it. There's four registers which may be getting altered by this, which are actually being used. The values are depended on later on, so I did push to the stack pop from that. None of that actually fixed the bug. What I did to fix it in the end, because of the possibility that screen memory has been overwritten, I actually moved where all the variables for the game are. In this framework that I'm using, there's normally an include, which is for variables, and it actually happens. It happens before a line that includes another file or another two files, one of which is called line2.asm, the other one is screenfull.asm. And these two files are basically like meant to go actually at the end of the assembly program. So line 2 actually represents in the assembled .p file the second line of basic. All the assembly code goes in the first line at line 0. And so yeah, that was a bit suspicious that I actually had my variables after screenfull instead of before. So this is the fixed version, so I changed that around. Now here's the debug print registers routine there. So first it saves all registers, and then at the end it restores them all. It prints out all this debug. So yeah, in the latest fixed version, that's this one. I'll just demo that, and I've pretty much tested this quite a bit. So even though the place where the bug happened moved around when you reassembled it, and all around the screen, and it actually looks like it runs faster as well, which is pretty cool. Quite pleased with that. There was, if you notice on the original, a little bit of a delay every time you collected food, and it had to recalculate the length of the snake, but it seems to be working perfectly now. So yeah, thanks for watching. That's the end of this video now. If you like it, download the game with the links below. Carry on playing this for a bit. Might add some joystick support later as well, actually.